Hello, everyone. With robotics, large machinery, and world records, this company is not just imagining the next frontier of large-scale thermoplastic composite 3D printing. They're literally building it one layer at a time. Let me introduce the CEAD Group. Hello, everybody, and welcome to another live episode of Builder Nation. Today, we are joined by currently their CTO and co-founder at CEAD, Maarten Logtenberg. Maarten, thank you very much for being here with us today. Could you please introduce yourself a little bit to us?
Well, thank you, Sam, for having me over. Indeed, my name is Maarten Logtenberg. I'm the co-founder and CTO of CEAD Group. This company started 9 years ago on an endeavor of bringing large-scale additive manufacturing to the markets. So 9 years later, indeed, we have built the biggest 3D printer so far, and trying to push the boundaries of what we can do with this technology.
And that's honestly something that I'm really excited to talk about. So thank you very much for that quick intro. Thank you very much for being here with us today, Maarten. The first thing that I wanted to touch is something you already mentioned, right? It's somewhere there in my question list, which is that you built, like literally built the largest 3D printing machine. It's, if I'm not wrong, like 40 meters long. If I'm not wrong.
Yeah,
like. I mean, that's too big. I only imagine the 3D printers like this machine that is the size that it goes on the left side of my desk. That's it. How did that come to happen? What does it do? Such a big machine.
Yeah, well, we were of course lucky to meet the customer that actually was looking for a machine like this. And this customer that is active in the maritime industry, so boat building, and you can imagine that boats that they can become very big. And this customer that had this vision of 3D printing actual boats, so you need a big machine for that. Yeah, quite a big machine. So far we had experience in building some large machines, but this was definitely a new challenge for us. But our firm really likes to grasp a challenge and see what we can do, and in the end we managed to provide. So that's always a good fun.
I mean, it does sound like a lot of fun. I mean, it's amazing. You literally build you built a machine to 3D print a boat. It just sounds so futuristic. So, thank you very much for that. Now, you already, with this answer, you gave us a little bit of an overview of what the CEAD Group does, right? Which is not just building machines for 3D printing, but actually customizing them to their needs. So, I wanted to ask, first of all, what was the first product that the CEAD Group developed beyond a classic 3D printer?
Yeah, so the first product in the 3D printing area was actually a very large machine called the CFAM. It stands for Continuous Fiber Additive Manufacturing, and basically this was the same sort of design as a desktop 3D printer, like a 3-axis machine where your bed moves up and down. The only thing was that that machine was quite a lot bigger. It could actually print the size of a car. And this was the first machine we tried to build. And it was quite an engineering challenge, and it took us 2 years roughly to build the first machines. But in the end, we managed, and they're still producing right now with two customers that have them working in their factories.
Wow, that's honestly really amazing. And what sort of challenges come from trying to scale up just a regular 3D printing machine into one of these super vastly large machines to print cars and boats?
Yeah. Well, one of the challenges you have, of course, is that you need to gain a certain speed. If you're going to scale up your desktop 3D printer, and you're not scaling up the amount of material you can extrude, then it's going to take you weeks or maybe even months to print something the size of a car. So that's, of course, something that is not gonna happen. It's in an industrial environment. You also need to have a return on your investment. So you need to scale up the material output. So the first challenge we had was actually building an extruder, which was capable of producing enough throughput, enough output to make this technology, money-wise, make it sense for our customers to use this as a new production technology. Furthermore, everything becomes bigger. So yeah, creating something that is straight on this size is already a challenge by itself. But you have to deal with temperatures. Of course, we are using high temperatures for melting the thermoplastics, but your structure, your machine will expand and stuff like that. Without it's not allowed to bend, and the printing itself. Everybody knows what warping is with 3D printing.
Hmm.
If you have experience with 3D printing, it's always a shame if your print fails due to warping of your print. So that's one of the challenges we needed to conquer during during scaling up of the technology.
All right. Well, thank you very much for sharing that. Honestly, it's not really something that I would have expected to. I mean, definitely challenges I assume were expected, but not so specific ones. Thank you for that. Now, I wanted to ask you something regarding to this tech. That you already mentioned that it took around 2 years to bring. At what point of development, or maybe it was not in this machine, but in some others, when did you actually include it or started working with robotics for your
Yeah.
printers?
Well, when we launched this machine, this was the gantry machine.
Mhm.
Um, uh, it was still in the beginning of large format 3D printing. There were only a handful of companies working on this topic, and it was entirely new for the industry. So when we showed the parts, the questions we got is, can you make it smooth? Because everybody saw the printing lines, and they're a lot more there than if you print on a small scale, because we
Right.
print with larger beads. So we always try to listen to our customer and learn from them. And they were asking this question, can you make it smooth? And then we said, of course, yeah, you can sand it, or you can do some manual labor afterwards. But then the investment doesn't make sense anymore, because then you have a lot of labor in sanding something down. So we decided, okay, we need to investigate this topic. But we want to combine the 3D printing, the additive manufacturing, this is our expertise, then with a technology to make the parts smooth again. And that's how we came up with the robotics. We felt like this could give us a system which was really flexible in that sense, that we could use it for both 3D printing as for other technologies. And that's also why we call the system the AM FlexBot, because it's a
Mhm.
flexible machine we can use for several purposes.
All right, and actually, you already mentioned a few of the things that I wanted to ask in a more general way. So you already mentioned the MFlex, but you already mentioned your gantry printers. Let's scale back just one or two steps. Could you please give us an overview of these tech and what they do,
Sorry, of these what?
of this technology and what they do?
Oh, yeah. What can you do with these machines? That's a good question. Maybe we should have started over there. Yeah,
We got excited. We got excited.
we got excited. Yeah, of course. So basically, of course, it's a new production technology. So lots of things are going on in terms of material science and in terms of applications. So one of the first use cases for this technology was basically making tools and molds, because it's far more cost effective. We use less material to make a tool or a mold in a more automated way. And it's easier to recycle the part afterwards. And you're not really risking you're changing the end use part, because the end use part is still being made the traditional way. Just the tools for making that part are changed. And this is still still a market that has huge potential in growing, because the way how we make the tooling, how we make the molds is really evolving, and especially the materials as well. And then of course we have the end use market, where we're not making the tools of the molds, but we're directly producing or manufacturing end use parts. And this could be anything from furniture to boats. So that's quite a wide range of applications we have there. And this is being enforced by the amount of materials that are available.
Right.
The technology that we use allows us to use very common materials like polypropylene. In Holland, the milk cartons are made out of this material. I'm not sure how it is over there, but
I'm
it's a
pretty sure
very
just
common
started.
material. Yeah, probably. Yeah, could also be the case. And then up to very high-end materials, very costly materials like PEEK. And PEEK is mostly used for the aerospace industry or the oil and gas because of its certain properties it has. But this is a very wide range because any thermoplastic material in between can be processed by this technology. And that every material has different price classes, but also different applications. So yeah,
That does trigger a question to me, which is, I mean, you already mentioned that you have a very wide range of materials that you can work with, and also that there is a very wide range of applications, right? From furniture to boats. How do
yeah,
you work with your customers to determine which is the best material that fits their needs?
yeah. So of course we build up quite some knowledge internally over the years in using this technology. We do a lot of material trials with material suppliers. So they come over or they send over their material, and we do a lot of testing and conducting tests on their material to see the printability, but also see what's the strength after printing, how does it behave. But when a customer comes to us, they say to us, okay, I need a material that is can be in this price range. It needs to be UV resistant because it's going to be used outside, and so they have
Right.
some general yeah, technical like remarks they have on the end use part, and then we already have like a selection ready based on our experience on the materials we can use. And if then we're still in doubt of what the best material is going to be, then most of the time we're doing an application project with this customer, because the customer also needs to learn that they need to change their production methods by
Mhm.
using these machines. They're used to different methods in their factory. And during this pilot project or this application project, we look at the design, we look at the materials, we actually manufacture the part in our in-house with our
Right.
machines. And then the customer can actually try it out in the field, get a feel of how the part is behaving, how it's holding up, and if it's actually suitable for using for his production, yeah, and his company.
All right. So for what I understand, you literally provide the full range of not just designing the machine, but also actually doing the test runs first to then make sure that you get it perfect before they sort of add it to their own production, which is actually
Yeah,
pretty cool. All right.
yeah.
Thank you.
Yeah, nobody likes a customer that isn't happy with what they purchased. So we rather invest the time on beforehand and make sure that they really have a use case for it.
Yeah, no, I agree with that, and actually that was a question that I wanted to ask you before. You sort of already answered it, but it was pretty much about this process of how long does it actually take to finalize, these custom machines for customers. I would assume that just building a machine from scratch is already challenging in its own, let alone doing it customized. How is that process?
Yeah. Well, of course, it depends a little bit on the size of the machine and whether we built something similar before or not. And
Hmm.
similar, I mean, not exactly the same, but going the same direction.
Yeah.
We've been scaling our production capabilities quite a lot last few years. Um, and right now, if we have like an average system size, which can print about the size of a car, then we can deliver a machine in roughly 4 months. Depends, of course, still on the amount of customization that is required.
Hmm.
Um, we also sell just the extruders. Those we can deliver out of stock currently. This has been a huge challenge for us as well, due to, of course, all the Corona supply chain issue everybody
Yeah.
faced. So we're happy that that's finally solved. But actually, to give you an example, the 40-meter machine, which was a really custom machine for us, the first time this size, you have a lot of engineering challenges. Um, you can imagine the machine was going to the Middle East, so we also need to deal with the climate over there and stuff like that. That took we delivered within a year. So from engineering to actually manufacturing to shipping it over and installing the machine. So it was a team effort, and the client was very collaborative in that sense as well. But yeah, these very big projects take us roughly a year.
That's actually pretty interesting. I didn't really know it could take that long. I sort of expected it, I guess, but thank you very much for giving us that insight. This also triggers one very quick question. Do you actually have service for every country, or do you have like a selection? I mean, you mentioned this went to the Middle East, right? So,
Yeah. We sell our machines worldwide. Actually, 99% of our business is not inside the Netherlands, so we need to travel a lot. We are actually right now we are in the process of opening a hub in the US, so we can serve our US customers directly from there. I believe yesterday we received our phone number, US phone number. So small steps, but there are steps. And we are also looking creating a hub in the Middle East, but those are this is in the very early stages still. But so far we have been handling our customer service very good from within the Netherlands and servicing our customers. We always keep in mind that our machines are going worldwide. So we implement systems that we can actually monitor the machines from the Netherlands, and we can push updates from the Netherlands. And so that's helpful in how we set up our infrastructure in making sure the customer gets helped really fast. But of course, the more customers you get in a certain country, the more interesting it becomes for us to set up some local, either through a partnership or do it ourselves.
Right, I would assume that's what happened in the US, right?
Yeah, the US we're going to actually set up ourselves. But other countries we also have resellers or agents, and on behalf of us they can help their customers as well.
Right. Well, that's actually very, very interesting. This triggers a couple questions, but the main one that I wanted to ask you is regarding maintenance. I mean, if you provide these machines, very large machines everywhere in the world, and they're customized, it means that it has to be somewhat complicated to do maintenance to these devices. How do you handle that? Do you do trainings? Do you leave a manual? How does that work?
Well, it's a multifaceted problem that we need to tackle because indeed they are large industrial machines. So and they require, just like a car, they require maintenance. You can try to run them for 5 years without doing anything, but I don't recommend doing that. So so of course we have manuals. We are obliged to make those manuals and deliver them to our customers. We give training to the customers. So the process is when we build the machine, we build them right now in the Netherlands. Then we take them apart again. We ship them to the customer. Then a team of 4 or 5 people will come over to your factory and they will build up the machine again. So this takes, depending on the size, 1 to 3 weeks. And then another team arrives, and this team will actually give training for more than a week at the customer's facility. And this training includes safety. How do you handle, how do you operate a robot? This training includes how to program it, the software, how to design for 3D printing, but also the maintenance. What is the maintenance the customer can do by itself? And there's maintenance that needs to be done by us. And these are scheduled maintenance, so once or twice a year.
Right. I mean, that
so
makes
an entire program.
Yeah, that makes complete sense. But I believe that I've never actually encountered a company that has such a large process of this deliverability, right? It's not just building the machine. It's also, you mentioned already, a few weeks of going there, training, setting it up. It's pretty interesting. I cannot even imagine how it was for your 40-meter one.
No, it really is a process. And that's also why we find it really important that we're not selling a machine. So it's not something you can order on a web page and we never talk to you. No, we are really selling a partnership, because you need to go through this process together. We need to look at the factory layouts on where we're going to place this machine, the power supplies, the air. It's quite a process on a collaboration on actually getting this machine up and running over there. It's a bit different than a desktop 3D printer. That's for sure.
Uh, I would say a bit is sort of an understatement, but
Yeah.
yes, it's definitely different. Now, I wanted to ask you something a little more about your specific job on this, right? I mean, you're a mechanical engineer, so
Yeah.
do you like spearhead these like these efforts into building these very customized machines, or do you have a designated team? Do you handle something else? What
Yeah.
is your role in this?
Well, as being the co-founder of a company that is growing, your role changes every several months. That's just how it works. In the beginning, I was doing the finance. Luckily, I'm not doing that anymore.
I did not expect
that's just
finance.
yeah. That goes go with the flow and do what you need to do in order to keep the company growing. But luckily, when you're growing, you also have the possibility to hire professionals, so that are good in their job. Currently, my role is almost entirely R&D. So I'm running quite a big team of hardware and software engineers on making sure that we deliver and develop the next things. So improving the machines, a lot of software is involved. Really focusing on our 5-year vision. And of course, I'm involved with the big projects, the big special projects still as well. But we have project engineers that are actually
Mhm.
running those projects. So
Right.
if we have a project like that, we assign project engineers that are going to do solely that project, while I'm more focused on the R&D stuff. So the new stuff
Right.
that's coming up. Yeah, yeah,
That's very exciting. Now, I want to ask you down that line of R&D. Do you have maybe any? Let me rephrase. What are those innovations, maybe in hardware, maybe in material science, or maybe in engineering, that that you're really excited to try out, or that you're actively working on in the industry?
yeah. Well, of course, I can't tell everything. I mean, some
No, of
things we need
course.
to keep secrets, but now
Spill the sauce.
I
Spill it.
think what really is important is um, we are introducing still a new technology to the market. For a lot of people, this is still a new technology.
Yeah.
And if the experience with this technology is they find it difficult, or it's difficult to implement, or it is difficult to design something that can be 3D printed, or if your print fails halfway,
Right.
then then you start to dislike the technology. So and this is something we don't want, because in order to gain traction, to gain market traction, what we say, it should be a first time right. So all of our efforts are focused on creating a machine, creating a process. So not just the machine, but also the software upfront, but also the reporting afterwards, that tells you your print actually was made up to standards. Is all based on first time right. So if you have a design, if you want to print it, then first you need to have a review of that design, automated by software, whether it is printable. Because otherwise you should never start it. I mean, it makes no
Mhm.
sense to start a print that can't be printed. During the printing itself, it should be monitored so that the process conditions are as they should.
Mhm.
This sounds very logical, but it's quite difficult to achieve. Um, and then afterwards, we should have the reporting. If we're producing parts for the aerospace industry, you really want to make sure that the part is up to specs. Um, and this entire ecosystem has a lot of different factors. It's the reliability of the hardware, it is the reliability of the software, it's a prediction, and it all needs to come together. And that's our focus on creating that.
That is very interesting. I mean, a person that is not related to it cannot possibly imagine just how broad this focus has to be. It's honestly amazing. Thank you very much for that. But let's circle
Yeah.
back to the printers themselves, right? And now, so far you have already mentioned, the gantry printer that you have, or the gantry based, robotics based, your large scales ones. But I noticed there is another one, which is a bead hybrid solution, right? Which you made in
Yeah.
partnership with Bellotti SPA. Could you please tell us
Yeah.
a little bit more about this one?
Yeah. So Belotti is a known CNC machine manufacturer. So they build CNC milling machines for quite some time right now, and they're very good at it. And they build very nice 5-axis CNC milling machines. What we saw, especially a gantry CNC 5-axis machine, is not the same as a 6-axis robotic arm. If your main goal is milling, because a gantry machine will always be superior in terms of stiffness, in terms of accuracy. It's very difficult to beat that because of the kinematics, how that works. We can come close with robotics, but again, a gantry CNC machine will always be superior in terms of milling capabilities. So in order to serve that market well, because we have a market that wants to use robotics because they're mainly going to do 3D printing and then maybe some milling with it. But the customers that mainly want to do milling and some 3D printing are better suited with a bead machine. And then you can try to reinvent the wheel by making your own gantry 5-axis CNC machine. But for us, that didn't make sense because this is a mature market. There are a lot of players working in that market. It's a difficult market to get in between if you're a new player. So we said we are very good. Why try to compete on something we're not that good at, or we don't want to build a track record in? Let's just partner up with a company that has a track record in doing that very good. So that's how we came up with the creation of the bead machine, hybrid CNC milling and 3D printing. And we feel like it's a very good solution for a lot of our customers.
I mean, it's honestly pretty unique. The way you describe it is actually pretty cool. So thank you very much for that. Now I understand that this is basically like multiple processes into one single printing cell, right? So how challenging was it actually to develop this device that is accurate, reliable, and doesn't really have like a lot of problems? Was it easy combining the tech? Was it very challenging? How was it?
Well, it was for sure was not easy, especially if you're combining stuff. So for the large format 3D printing, you don't need that much accuracy. I mean, of course, you still want to be accurate, but you're printing very rough lines, so you have some play in there. But if you're going to do CNC milling, you will see every defect. You will see it. So even if it's like a tenth of a millimeter, very small defects, you will see it right away because you're creating a smooth surface. So to achieve accurate CNC milling with our robotic system, we partnered up with Siemens in order to actually use a robotic arm, but without the robotic controller. But we took a very high-end CNC controller made by Siemens that's normally being used on the very high-end CNC milling machines.
Right.
And we use it to control our robots. I will explain you why, because robots are normally, they're originally made for car manufacturing. You know, these lines of cars being manufactured, and they're mostly doing spot welding. So robots are very good at moving from a point to a point and ending up at that point. But the trajectory towards that point doesn't really matter in car manufacturing. It just needs to be fast. But it needs to end up accurately, but the path itself, and then what you will see is the path itself will mostly be made out of circles, because a robotic arm has only rotating joints. So it will always, by natural movements, are more like circle movements than straight lines. While a gantry machine, its natural movements are straight lines. For controlling a robot to make sure that it actually does accurate straight lines, you need a controller which has very high computing power and very advanced algorithms in order to make sure the robotic stays within its path. So this helped us really to create a robot which was accurate. And also that has a CNC controller, which makes the step for a lot of customers that already have a CNC machine very easy to start using a robotic arm. They don't need to learn a new language. We use standard G codes, which you probably know from 3D printing, to control a 6-axis robot. So that's pretty cool. You can just program X, Y, Z, and it will do the rest by itself. So it makes it a lot easier to use the machines as well. But then going indeed from 3D printing to milling and combine that in one machine, you get a lot of challenges. You can only imagine the amount of electrical connections you have. And we have water cooling,
Right.
and you have material hoses going there, and they all need to be able to be disconnected and coupled again. And so, yeah, that was definitely a challenge, but yeah, we managed. But now we're trying to add more technologies, and that brings more challenges as well. But keeps things fun and interesting, right?
Hey, challenges where engineers thrive is what they say.
Yeah, yeah,
So
yeah. I believe that.
I
Yeah.
agree. I agree with that as well. Thank you. Just one quick question: how long did it take to develop the bead hybrid?
Well, together with Belotti, it was actually quite fast. I think we had the first machine up and running in within 6 months. Um, uh, yeah, I think the reason being is that Belotti already had a very stable platform, and we also had a very stable platform with building our extrusion technology and printing heads, and we combined forces and managed to get this working.
Well, that's actually pretty fast. I guess I expected something again like the 2 year mark that you mentioned for your other
Yeah.
machines, but it's great that it was so fast. Now before carrying on, we've already crossed the 30-minute mark over here. So I just wanted to say to the viewers that we have out there, thank you very much for being here with us today. Don't forget to subscribe, and if you want to start leaving any questions for Maarten right now, feel free to do so in the chat so we can answer them just very quickly. Maarten, going back to this, I want to ask you a little bit less outside of the part of the R&D that you do on all of your machines, and more into the process of building this. You already mentioned a co-founder is sort of a it's sort of a do-it-all, right? That you have to work on every side of the company. And with R&D specifically, what are the challenges that you normally typically face the most, let's say in supply chain, in procurement, in maybe the delivery? What are some of these challenges that you have overcome?
Yeah, well, indeed, growing as a company and getting a bigger customer base, you're faced every year with new challenges, and it really depends on the company size you are. So of course we started with just 2 people, and then now we're over 60 people. So it's and along the way you face a lot of challenges, but I think really scaling up the production, being capable of delivering more and more machines every year while maintaining the quality and the partnerships with our customers during a time like COVID, that was
Right,
quite challenging, but also a lot of fun because you get to implement new systems, you get to implement enterprise resource planning systems. You're setting up a warehouse, you're setting up purchasing systems,
right,
um, you're setting up quality control systems. So every time when you fix something, you find something else that becomes the new bottleneck, and this keeps things fun as a founder in running a company like that. It's never a dull moment, always a challenge. Um, but expanding gives you a lot of new opportunities. So you get to be working with a lot of great people. The team is expanding. You have a lot of experts in house. Yeah, of course, you have some more money you can invest on certain topics. So yeah, I think that is great. But um, right now when you're growing as a company and at the size that we are getting right now, then how are you managing everyone and everything and make sure that everybody is aligned? In the
right.
beginning, you did a daily stand-up, but now you can't anymore because it's too big of a team. So you need to split it up and you need to do it differently. But yeah, all very fun challenges to work on. Yeah.
And out of these challenges, rather out of this trajectory, I mean, you mentioned it. You started with 2 people. You've jumped into being 60. Did you have a moment, like a specific moment, where you actually sort of like sat down and thought, "Damn, we're doing it. Like we've come so far." Maybe it was setting up that first ERP or selling the first
Yeah.
machine.
Well, you have a lot of highs and you have a lot of lows. I mean, that's building a company. It's all about. But I can remember one moment in time that um, uh, at some point you get to accept that you don't know everything anymore, because it's around 20 people. Then you need to accept that it's okay that you don't know everything anymore. Um, but in order, I did notice that I felt disconnected with certain departments, and that was growing.
Right.
So what we set up is we started this thing. What we're still doing is the end of the month presentations, and every department will actually give a presentation about what they have been doing last month, what they have achieved, what the progress has been, and what they're going to do the coming month. So every department gives this presentation to the entire team. And the first time we did that, I almost got a bit emotional because I really realized that it was perfectly fine that I didn't know everything anymore. Even it actually what happened was that I got to learn that I need to let go because things are happening then. You know, they really did a lot more than I was expecting, and really some cool projects and cool stuff. So I almost got a bit emotional back then. I was like, okay, this is really becoming something big. Yeah, so that was
Wow,
one of those moments. Yeah, yeah.
that is really cool. Thank you for sharing that moment with us. I, I I definitely understand and agree with you that I believe it's sort of like the co-founder syndrome, if you will. That it's sort of hard to let go your baby, right? It
Yeah.
sort of feels it feels like that is something that happens very oftenly. Thank you very much for sharing that. Now, jumping into the end of this interview, I just have a couple more questions for you. Number one is, you're a big player already in the 3D printing world and industry, right? Where do you envision the large-scale 3D printing industry going, and what role do you believe the CEAD Group is going to play in it?
Yeah. Well, it's difficult to say how big the market is going to become, because what we see that we unlock markets every day because new customers come to us with entirely new applications, and then you look into the size of that market, and you're like, okay, here we go again. So we still have a lot of untapped market, and we can't really predict on where it's going. What I do envision is that it really is going to be a professional, and it already is, but industrial common new production method. You know, allowing for a lot more customization, and that's huge benefits in compared to some other production technologies.
Right.
For us as a company, we really enjoy doing the bigger high-end projects. I think we're good at it because we don't see ourselves as just a machine builder. We see ourselves as a partner, you know, going along the entire process in teaching you, in improving the technology, in teaching the customers, customizing the machine for their needs, and implement it in their production environment. And what we're envisioning is that we're going more and more from just single machines to entire factories. So we are already doing this. We're already working on some projects where it's not
Wow.
just one machine, but several machines in one building. And then you need to think about the entire ecosystem.
Yeah.
And I will foresee that this is becoming more and more. And this will bring new opportunities and new challenges in how we're going to manage all these different machines in one factory, and they need to work together, and it's going to be 3D printing and the CNC milling and probably some more technologies along the way as well. But one thing that is important, and that we really teach our customers how to use this technology, what you can do with it, and keep our R&D efforts on that first time right focus to make it easier and easier. It would be great if one day my mother could start the machine without my help. That would be that would be amazing.
I mean, I feel that's the perfect example to put it on a just set it up and forget about it.
Yeah,
Thank you very much for that. Now, I did mention that I had two questions, but you sort of triggered one that I think is going to be really. It's interesting to me. Out of all of your customers, have you had one that you think the product was maybe too unique, or maybe it was a fun application that you were planning to do, or something you didn't
um,
expect?
well, I do have some customers, but I can't talk about their products, unfortunately. But
Oh,
I definitely didn't expect that market to be uh, that big.
right.
So far, I have not seen a customer that made the wrong decision in buying a machine. But I think that's also because we do this sort of due diligence together
Yeah.
before they actually can buy the machine, because they're costly machines, and it would be a shame if we invest all this time and all this effort in getting the machine to the customer,
Yes.
and it will there just be collecting dust. We're not doing it to make money. We're doing it to actually change the industry and to actually get the machines working and not catching dust somewhere. So far, yeah, it's been good. Yeah.
I really like that mentality, and I agree with you. You're doing it. You're really changing the whole industry. I honestly I never even thought it was possible to build such large machines. But I believe that we're getting ready to the end of the interview over here. I only have one last question. I also believe that we covered every topic pretty well because it doesn't really seem to be any live questions right now. Don't worry. At some
Right.
point, they're gonna appear. Maybe after the video is posted. But for
Yeah,
now,
that's
I
fine.
have one last question for you, Maarten, which I believe is one that is going to be very impactful. As a co-founder, as an engineer, what is the advice that you would give any young person out there who's starting their own path, engineering, in entrepreneurship, maybe in the industry? What is that advice you have?
Yeah. It's a good question. It's always a difficult one to answer. Um, but I think that the if you have a passion about engineering, if you have a passion about trying to get a product to market, uh, yeah, it's gonna be a difficult road. But you can skip a lot of bits, or how do you call it in English? I don't know. But you can avoid a lot of mistakes by actually seeking advice. Talk to people that are like 3 or 4 years further than you are, that are still also building their company, that are still that been there. Talk to those people. They're always happy to share. They always like talking about their adventures, and it will save you a lot of mistakes. So yeah, get out there, talk to people, talk to your customers as well. Don't just engineer something and hope you will find a market fit. No, that doesn't work like that. Then you will also waste a lot of time and effort. You need to get out there, talk to potential customers, and talk to people that have been before you. It will save you a lot of headache.
Thank you very much for that advice. And you already heard him. Work on your networking and don't be afraid to ask questions. Thank you very much, Maarten. Now, following this same line about going and reaching out to people in there, where can we find you and the CEAD Group? Do you have any social media handles? Here?
Yeah, of course. We have profiles on LinkedIn, myself included, but our company as well, CEAD Group. Of course, we have a website, and we are also a little bit active on Instagram.
That's amazing. And by the way, your website is incredible. I really love watching your machines and those videos, like with the
Yeah.
robotic arm and everything. It's very fun. It's super cool.
Well, great. I think we will put the link to the website in maybe in the comments of the video, or
Let me put it right
then
now.
people can find it if they want.
Right there it is. Thank you very much for
Great.
sharing that. I already
Thank you,
shared the
Sam.
link. And now everybody else, just please don't forget that you can find more information, interesting articles, and a lot more interviews directly on our website, buildernation.io. We're gonna love to hear from you. Thank you very much for being part of this community. We're gonna see you the next episode. Maarten, do you have any last comments?
Well, thank you for having me, Sam. I enjoyed this conversation, and I hope that we teach some people some new information and get some questions going.
Well, I know I definitely learned a lot. So,
Good,
Maarten,
good.
thank you very much. We were so lucky to have
Thank
you.
you.
Goodbye, everybody, and thank you very much.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic 3-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.